Here is a very brief overview of the guided specific heat lab. This should be a pre-lab that the students should work through individually to make sure they understand the procedure and the calculations before starting the real lab. So the students will be using a triple beam balance, some temperature probes, 2 cups, one that will eventually hold hot water and one that will hold an unknown fluid. Okay, the first step is students should get the mass of the cup in which they will put their unknown fluid. So when they're doing the virtual part, they should scroll down. They should get the best estimate of the mass of the empty cup. Okay, once they have the mass of the empty cup, they will then add between 50 and 150 milliliters of their unknown fluid. They'll put it back on the triple beam balance. And again, in the virtual world, they will then get the new mass. They could then subtract from the mass of the cup and get the mass of their unknown fluid. Okay, they then put a vernier temperature probe into that unknown fluid. They then get their second cup, the one that will eventually hold the hot water. They should have a temperature probe in there and be prepared with their software to start collecting data. They want all this ready before they get the hot water. In the next step, they actually put the hot water into the cup. They should start monitoring the temperature of the two fluids. When the temperature probe hits equilibrium with the water, that is, it stops rising, they should mix. They don't want to wait too long because it's losing heat to the environment. When they mix, the two temperature probes will both be placed in the cup with the fluid. The two temperature probes should reach the same temperature. This should be our equilibrium temperature. So students should use this graph to get the temperature of the hot water and the unknown fluid right before they were mixed. They should then use the graph to get the equilibrium temperature. They should do this as soon as the two objects reach the same temperature, because the longer they wait, the more energy that is lost to the environment. Okay, once they've got all their temperatures, they then weigh the cup that has both fluids mixed together. They get the mass, they subtract from their previous mass, and they can get the mass of the hot water that they added. They now have the 3 masses that they needed, that they measured. Again, they subtracted the empty cup from the cup in the unknown to get the mass of the unknown. Then they subtracted the mass of the cup and the unknown from the cup and the mixture, and that gets them the mass of the hot water. With these masses and temperatures, students can calculate the heat lost by the water because they know water's specific heat. They set this heat equal to the heat gained by the mystery fluid, and they can then solve for the specific heat of the mystery fluid. Once they have their answer, they should type in their answer in joules per kilogram degree Celsius. They should put their name and then hit submit. Obviously, we didn't get it right because I didn't even enter any numbers, but the students will get a message saying either they got it right or that their numbers were incorrect. If their numbers are incorrect, it will show them what the true value should have been so they can find the error in their calculation. If they do get it wrong, they should start it again. Once they get the pre-lab done without error, they should show you the certificate on their mobile device or on their desktop computer, or even email it to you, and then that will let you know that they know what they're doing for the real lab.